Hey everybody, welcome to Geometry. I'm your host, Mr. Briggs. Alright, today we have Unit 5, Topic 4, Applications with Right Triangles. So, whole time we've been working on trigonometry. The big thing about it is that right triangles are everywhere. This is how explorers used to travel the Earth. It's used just navigation, surveillance, surveying, all these different fields. So, before we get started, just want to go over some important vocabulary. We've got two things, angle of elevation and angle of depression. So the angle of elevation is an angle that measures up from the horizontal. So if you have a horizontal line, the angle of elevation would be up from that horizontal line. So the angle from the horizontal up to the object. The angle of depression is starting at the horizontal and going down. So imagine if you're looking down at an object, that'd be the angle of depression. If you're looking up at an object, that'd be the angle of elevation. The interesting thing about that is that they are equal. So sometimes a problem will give you the angle of depression, and it's easier to draw the triangle this way. So you would just say that that's equal to the angle of elevation because these are alternate interior angles. And alternate interior angles are congruent. So let's take a look at a problem. Let's hop right into it. We have here some steps for how to do these problems. So step one is read the problem. So take a moment, read the problem. Then read the problem again piece by piece. And as you're doing this, you want to either label the given diagram or draw your own diagram if it doesn't exist. So let's do that. You are a spy on a top secret mission called Operation Geo. The helicopter that was sent to extract you is hovering 27 meters above the landing pad extraction point. So if we have a helicopter, there we go, and it is directly above the extraction point. And I won't call that X, we'll just make that a circle for landing pad, and we'll call this 27 meters. Okay, we are creating our own diagram. That's okay. And you are somewhere over here, and the helicopter's pilot sees you are at an angle of depression of 15. So now the helicopter's pilot is up here, of course. So from the horizontal, they see you at an angle of depression of 15 degrees. Okay, so this is, you might be able to start to see how we're going to get our right triangle here. This right here is your angle of depression, and that's 15 degrees. Now this is what I was just talking about. Sometimes our triangle doesn't include the angle that we're given, but since we know that the ground is horizontal, we have alternate interior angles. So this is also 15 degrees. Your angle of depression will be equal to the angle of elevation. How far away are you from the extraction point? So we want to know this, and we want to clearly label what we're trying to find. So this is going to be X. And we want to also label the triangle sides with opposite, adjacent, and hypotenuse. So here's our angle. The opposite side would be over here. I'll do a different color. The adjacent side would be right here. And the hypotenuse would be right here. Now what I like doing is writing down what I have. So I have the opposite side. We know how much this opposite side is. It's 27. And we know how much the angle is. So you have the opposite side and the angle. We need the adjacent side. So based on this, we see that we have the opposite and the angle. We need adjacent. The trig function that has all three of these things is the tangent function. Tangent, if you remember, is opposite over adjacent. So plugging in for everything, we have tangent of 15 equals 27 over x. So now you can go and plug this into the equation solver and see what you get. So I plugged that into the equation solver. I made sure to use the degree symbol just to be sure that we were talking about degrees. So that's that button right there. And we see that x equals 100.76. So the last thing that we need to do is make sure that we round correctly. So this is 100.76. We need to round to the nearest meter, so that is roughly 101 meters. So this side, 101 meters. You are 101 meters, roughly the length of a straightaway on a track from the extraction point. There you go. All right, so let's take a look at another problem. Two ships are sailing towards a 100-foot cliff. There's the cliff. There's a person on a cliff. There's one ship. There's two ships. The angles of elevation to the man standing on the cliff are given by the measures below. So everything is already given in our diagram. We don't have to really label anything quite yet. We need to determine how far the ships are from each other. So really the thing that we are going to be concerning ourselves with is this distance right here. But if we're looking at this, that's not really a part of a right triangle. So we need to consider this pink right triangle and this blue right triangle separately in order to figure out this problem. So let's just work with what we know. Let's start with the blue triangle. We are going to need to try to find this length right here because that's the distance that we care about. So take a look. Think about which trig function we're going to be using. So you should have said tangent because we have the opposite side. We have the op, we need the adjacent, and we don't care about the hypotenuse. So we have the op and the angle. We need the adjacent. So we're working with tangent. So the tangent of 45 is equal to opposite over adjacent, 100 over x. Plug that in to the equation solver, see what you get. See that x equals 100 as well. This is an isosceles triangle. This should make sense to us if we think about it, because if this is 45, then this is 45. And that means that this is an isosceles triangle with the two congruent angles, meaning we have two congruent sides. So x is equal to 100. Now, I'm going to label this pink distance here. I should have done this little blue and the bigger one pink, but this distance right here, we're going to call y, just so we can keep them separate. So we're going to set up our trig function here. Again, it's tangent of 30 equals 100 over y. If you're using your equation solver, you can plug in using x or y. I think it'll work for both. Alrighty, so here you have it. Y equals 173.21, but they want it to the nearest foot. Don't round until the very end. Okay, so don't try to keep some decimal places until the very end. So we know this whole distance here is 173.21. This distance right here is 100. So how long is this distance? It is 73 because it's 173.21 minus 100 equals 73.21. They want it to the nearest foot. So that's just 73. There you have it. So think about that. Think about the process that we used. Again, you have the steps up here to help you out. And we're going to go on to the third and final example for today. So, from the top of a 200-meter tall building, we read through it the first time, just kind of get an idea. Then we read through the second time and take it piece by piece, labeling our diagram. So from the top of a 200-meter tall building, the angle of depression to the bottom of the taller building is 30 degrees. So I'm going to put in a horizontal line here. From here, try to make it 0 degrees. Good enough. Okay, there's that. And the angle of depression is 30 degrees. So I'm going to draw a line down to the bottom of the taller building, and that is 30 degrees. Okay? From the same point on the top of this smaller building, the angle of elevation to the top of this building is 40 degrees. So I'm going to come down. That's 40 degrees. Okay? We need to determine the height of this bigger building. Okay? So, looking at this diagram, we do know one height. We need to know at least one side length in order to help us out with this problem. So this side is 200 because it's a straight line directly across. But in order to know this distance, we need to be able to work with this right triangle. And as of right now, we don't know any distances in this right triangle. We don't know this. We don't know this. So in order to figure out this distance, we're going to need to know at least one other length in this top triangle. In order to do that, we can use this distance in this bottom triangle to find out the length of this red line. We can use this distance and this angle to find the distance between the two buildings. So, this is my opposite side. This is my adjacent side. And this is my hypotenuse. Again here, when you're doing the real life problems, it's just going to be a lot of tangent. Okay, so we know the opposite, we need the adjacent, that is tangent. So tangent of 30 equals, and we're going to call this distance x. Tangent of 30 is 200, opposite over adjacent, over x. We plug that in, and we find 346.41. 346.4. Let me make sure I round to the hundredth here. 410. Yeah, so that's about 41. Okay, so this distance right here, I'm going to change my color this time, is 346.41. So we know for this triangle now, we know this side, we know this angle, we need to find this side, and we're going to call that y. So tangent of 40, again, we need our opposite, have our adjacent, opposite and adjacent, that's tangent. So tangent of 40 equals y over 346.41. So we plug that in and we get 412.84. I'm going to round that to 0.84. I like rounding to the hundredth while I'm working. It's just nice. So that, again, that was 412.84. 412.84. Okay, so that is this distance right here. So now we want to make sure that we answer the question. Be sure you answer the question and round it correctly. So it's asking, how tall is this building? Well, if this building up to here is 200, and then up to here is 412.84, rounding to the nearest meter, we would want to add those together. And that would be about 613. So 200 plus 413 would be 613. And we'll add our meters there. So there you have it. Applications of trig. Just look for the right triangles, know your angle of elevation and depression, and you will be golden. Have a wonderful day.